Hello, my rubber hearts. Today's episode is a special one because we are stepping right into the heart of one of the most exciting movements in our industry, the push to make rubber truly circular. I had the chance to visit the Circular Rubber platform on site and talk with one of its founders, Enrico. Now, if you haven't heard of the Circular Rubber platform yet, think of it as a meeting place for the entire rubber value chain. It brings together companies, universities, startups, and specialists from all over the world with one big mission: to make circular economy a reality for rubber. They do things by sharing knowledge, running technical webinars, building databases of materials, and maybe most importantly, connecting people who have rubber waste streams with people who can recycle them and the end users who can put that recycled material back into products. Enrico and his co-founder Jan launched the platform because they saw a gap. Rubber recycling and bio-based alternatives are advancing, but often the information is scattered, the right partners can't find each other, and good ideas never make it to scale. CRP is changing that by creating a community of over 400 professionals and more than 100 organizations, from testing giants like Smithers to manufacturers like Datwyler. In our conversation, Enrico opened up about what circularity really means in rubber, what projects are already underway, and what it will take for our industry to embrace circular design and recycling on a big scale. So let's see what Enrico had to say. Happy watching. So, hi, thank you for having us here today. Could you please take us back to the beginning? What was the spark that led to the creation of the Circular Rubber platform, and what gap in the industry were you aiming to fill?
Well, Jan and I are both rubber product engineers, and we really wanted to incorporate recycled and bio-based materials into our products. And the reason was that multiple customers started to ask for things like this. Do you have experience with using recycled materials? And on the other side, we talked with a lot of compounders and rubber manufacturers. They weren't aware if you could recycle rubber in the first place.
Oh.
And this made me very curious. So together with Jan, we started to search for companies that are active in this and ask them how rubber is recyclable. So soon we realized that that was the first hurdle that people have to go over to understand that it's in fact recyclable. And then we realized that we needed to get a lot of knowledge, a big network on this. And currently we're trying to solve that specific knowledge gap for rubber engineers like ourselves. First, we prove that rubber is recyclable, and then we tell them how to do it.
You find it difficult to explain to companies that are very traditional that this can be done?
Yes, for sure. Yeah, they always have a lot of arguments why it is not possible. And then I explain, yes, it is difficult, but it is possible. Maybe you can incorporate even 5% or 10% without mechanical properties going too bad. And I think that would be the way to go, to approach what is possible rather than it's impossible at all.
Start small.
Exactly.
Yeah. So circularity is becoming a buzzword in many industries, but rubber is a particularly complex case. How does the Circular Rubber platform define circular economy in the context of elastomers and compounds?
I'm glad you ask, because I started the idea of the platform after the circular economy courses that I did on the technical university. And basically the circular economy has a very defined definition of what circular economy is, and it explains three important pillars. The first one is do not make waste, because if you don't make waste, you don't have to recycle it in the first place. So the second one is make products from regenerative materials, because if you can grow them within a human lifetime, you can make sure that you can produce and grow them in the future also. And the last one, and probably most important one, is to recirculate materials at their highest value. So if you have a small product and let's say a bicycle tire, and if you have a flat tire, you throw away your whole bike. That doesn't make sense. So if you just fix your tire with a small piece of rubber and you can use your bike again, you have a small effect on your whole bicycle, in fact. So you keep the whole product at a high level. For rubber, that goes actually the same. Because if you have a rubber compound that is unvulcanized and you cannot use it today and goes overdue, you throw it away, it would be 100% waste.
Yes.
In a lower technical application, it would be fine to use that rubber with a little bit higher MUNI. So therefore, this would be recirculating at a higher level. Of course, in the rubber industry, it's very known also to make rubber crumb and glue it with polyurethane, becomes a composite. I think this is not really recycling, but I'm very happy it exists. because in this case, we still make products out of recycling of rubber,
Yes.
Which we would normally use virgin materials for.
It is a circular product and it does not end up in the landfill.
Exactly.
Yes.
And in fact, this is better recyclable than rubber itself because you can crumb it and glue it once again.
Yes, indefinitely.
Yeah, indefinitely.
So who are the members of the platform and what does collaboration look like between raw material suppliers, compounders, recyclers, and end users?
Well, in fact, the Circular Rubber Platform members are companies and individuals in the rubber industry from wherever in the rubber supply chain. They could be raw material suppliers, distributors, compounders, manufacturers, but also collectors of rubber waste, such as tennables. We have devulcanization companies, pyrolysis companies, micronization companies, and everybody around that, so universities and laboratories. And so these are all members of the platform. And slowly over time, we have collected over 100 companies from all around the globe. And what does collaboration mean? Well, what we do is knowledge centralization. So by becoming a member as a company, you already help with that because you show your place in the rubber supply chain. And on the other side, it's very interesting to get inspired by what all the other rubber companies are doing. So this is already a piece of knowledge sharing. We have webinars where these people can effectively meet, and we do that every month. And this case, it also becomes quite an international and interactive way of networking with people from all around the globe. Mm-hmm. So direct collaboration is not really what the platform initiated, but in the end, this really comes into play. Because you can see behind you also, it's not only the community, it's also circularity support. And here we matchmake between rubber waste streams and rubber recyclers to prevent companies incinerating rubber. And in the last step, we do projects for impact, where we basically orchestrate a whole project around the difficult to recycle rubber. And then we make sure that all these parties involved start to recycle rubber. Mm. And a good example of that is our bicycle tire project. And here you see collected in the Netherlands, collected bicycle tires devulcanized into a butyl rubber sheet. This is with 5 different Dutch parties, and we were able to make new products out of it again.
Very interesting.
Yeah. So this is collaboration at last. Yeah.
It's a hub of ideas.
Exactly.
Good. The platform positions itself as a neutral facilitator. How do you balance the competitive interests of different companies while fostering innovation?
Yeah, I really like this question because it's a challenging one. Yes. In fact, we work with very big corporates, and big corporates are not allowed to talk with their competitors on many different levels. Luckily, they are allowed to talk about information that is readily available on the internet because it's open. Mm-hmm. So what we have created is a business ethics for people that use our platform, which very clearly dictates that we only share publicly available information and do not talk about pricing or that type of stuff. You would be surprised, but having this information in one place, that's the unique value of becoming part of the community. It's not that we have to have confidential information. Mm-hmm. And so for us, being neutral means that we do connect with a lot of companies. We ask them for what they are doing and how they approach, but it does mean that all the members pay a fee depending on the revenue, but it's not that there's one stakeholder of the Circular Rubber platform.
That dictates how everyone else moves.
Exactly, exactly. So in the end, they all have the same type of membership and they are allowed to present their works on the platform, but they do not have any say in where the platform is going, for example. So that keeps it independently.
One of your focus area is identifying and tracking material streams. Can you walk us through the practical steps the Circular Rubber platform is taking to establish reliable databases of rubber material flows?
Yeah, the rubber material flow is an interesting one because you have material flows that go into the rubber industry. You have material flows that go out the rubber industry.
No.
In fact, I am not a market analyst that has all the expensive reports on where virgin material flows go. But in fact, it's very interesting to understand where rubber waste goes in order to understand what we can do with it and how to increase the recycling rate of the rubber industry. If you look at the plastics industry in the Netherlands, for example, about 9% is being recycled, which is very low. But it needs to be increased. And so if you look at rubber, for example, there's no data. So what we do is we start to work on where the material flows in the rubber waste industry. And that's very important to map. And that's just a matter of market research. We use Eurostat from Europe. We use CBS from the Netherlands. data systems where you can find this information. But on the virgin side, that's where the market analysts come in.
How do you handle the diversity of rubber formulations, especially when additives and cross-linking agents complicate recyclability?
That's a good question. If you look at a rubber recycler that collects all rubber in one pile. I think for an ideal circular economy, we work with closed loops where the manufacturer handles their production scrap. They know what material that is. They would work with a designated recycler, and they get that recycled material back into their production. So you know what you have.
Yes.
In case of having these piles of rubber waste, we in fact also try to understand how it works. And if you look at the orchestration of a circular economy ecosystem, let's say, everything starts with collecting waste, then identifying waste, and then sorting, separating, and then starts recycling.
Yes.
And so for rubber identification, luckily, there's so many research projects going on different technologies. So FDIR, DSC, TGA, you probably know. Then you have LLIPS and Raman. And NIR, for example. These are all technologies that start to make it easier to identify rubbers without completely destructing them. So
exactly.
Yeah. So this is, of course, the big challenge. We work with some research groups that have been developing these technologies, and now we look at practical use cases for them. So, for example, I'd like to spoil here that we're working on the laundry machine seals. So in a laundry machine, you have a big gray seal that closes the door, which is not a black rubber. So much easier to identify with FDIRs, and then you don't have to do TGA and DSC. Basically, we think that for the closed loop systems, it shouldn't be a big deal because you know what you have.
Yes.
For not closed loop systems, you will basically working on simplifying this identification process. But that's a long way to go, especially with infrared and carbon blacks. So how to handle it is in fact trying to sort in the beginning. And if that's not possible, then try to identify a simple identification technology that fits with your feedstock. And most feedstocks already have a kind of legacy of their fillers, etc., which are known by the specialists. So if you're working with fire retardancy materials, for example, in a certain application, then you can assume already what has been used in the last so many years, and then you can kind of work with that.
Kind of guess what was inside.
Exactly, and then you can target your identification system on that. Is it easy? No, for sure not. And we have to try and find applications with these recycled material streams, of course, which allow using these legacy materials.
So I guess this would be an interesting challenge for people who are specialized in reverse engineering.
Exactly. No, this is a very cool industry to work in because indeed we try to understand what has been put into it. And at the same time, we try to still identify new purposes for this recycled material. And in fact, also for bicycle tires, it can be that in the past, plasticizers with high PAH levels were allowed and now not anymore. So how to deal with those legacy materials, this is a very big challenge.
Yes, I would assume it's the biggest one.
One of the biggest.
Can you share any interesting projects you're working on right now where you've managed to connect all the dots? A material stream in need of recycling, a recycler with the right technology, and an end user to use that recycled output.
Well, I think going back to the bicycle tire project, it's a really good example. So in this case, we identified the fact that bicycle tires can be recycled, and especially the big corporates like Schwalbe did put up recycling programs for bicycle tires. In our region, we did a small survey and we found out that many of these shops are either not connected to Schwalbe for whatever reason, or they were even too lazy to work with their very simple program already. So we identified that it would be possible to pick up these material streams and see what we can do with them. And the reason was that just some passionate recycling people here in the area were asking us this question. And we approached this from a technical side. So we connected a very early stage with a rubber devulcanization company, and we asked them if it would be possible to recycle bicycle tires. Well, they mentioned it needs to be separated from the metals and the patches, and in that case, it would be totally fine. So we just created kind of a small ecosystem of bicycle tire collections points here in the municipality of Zwolle. Then we started to, drive a car around to pick up these material streams. We have social workshops where people cut out the valves and patches, and then they get sorted and collected, and then they go to a devulcanization company. In fact, this project was already granted with a small grant to further develop the materials that we can make from this butyl rubber. And this is the first practical sample of it. So this is 100% Zwolle bicycle tire tubes. And now it's the matter of creating products with it. And we do have challenges with the legacy materials that are in there. So now we work with the laboratories here in the area to understand what are the applications for this material, considering the legacy materials. And what are the mechanical properties? What kind of products are typical to be produced with recycled butyl? And so now we go to the next step. But this is a really cool one where we connected 6 parties. And even internationally, we already had very good connections with England and France to, basically collaborate on this project.
That's very interesting.
Yep.
So you are trying now to identify possible applications.
Correct. If you have problems sourcing reclaimed butyl rubber, contact us and we can try to create a supply chain for reclaimed butyl rubber from bicycle tire tubes.
What are the main technical barriers you encounter when trying to recycle cross-linked rubber compared to thermoplastics?
The barriers of reclaiming rubber is, of course, the cross-linking between the polymers. This is, I think, the easiest. And I explain it also very simply to people that are not in the rubber industry. If it doesn't melt, it's a lot more difficult to recycle.
Yes.
So this is already the first step. The second step, I think, is the different vulcanization systems that you can have in the similar types of rubber, like EPDM, sulfur cured and peroxide cured. And they're both black. So how are you going to identify that without TGA or DSC? So this is already some of the challenges that we'll face. At the same time, if you're going to silicon rubbers or peroxide cured rubbers also, where you have cross-link with the C bonds, it becomes very difficult because the difference in strength between atoms is very narrow. So trying to break exactly the cross-links and not the polymers, that's of course
it's very difficult.
Exactly. But to be very honest, the thermoplasts also have problems with polymer scission. I do know that in PVCs, for example, you have polymer chain extenders.
What are the promising technologies like devulcanization, chemical recycling, compatibilizers that you think could scale within the next decade?
Decades take very long, and our startup just started about 2 years ago, centralizing knowledge on this. What I did learn is that, in fact, rubber has been recycled since a little bit before the Second World War already. So the fact that there's technologies that can scale and that can grow over time, I think that's clear. Slowly in the last decade, the pyrolysis has been growing quite a lot with footprint of recovered carbon black also, and you see many projects popping up in Europe now, pyrolysis plants. The reason why is that I think you can take a lot of material, the feedstock allowance is quite big, so passenger car tires or whole truck tires, and you have one process with a very high capacity, and you get a certain material that is, of course, fluctuating quality. I think it's quite a scalable technology. Devulcanization, on the other hand, is a little bit more difficult because you're depending on your feedstock and trying to optimize your process parameters. And with the complexity and the variety of rubber compounds, it's a lot more difficult to make the business case and to close the business case even more with the competing of the virgin materials. However, I think that there's some cool, interesting technologies coming up, like chemical depolymerization or devulcanization, where you can use with solvents, for example. And there's some companies and startups also in our network that have been working on solvent-based depolymerization, which are also a little bit less susceptible on feedstock dependency. However, these technologies are very young, so they have to try and find their place in the market. And also they have to work on their cost prices of operation. I think pyrolysis has a big place there. I think devulcanization still has a long way to go, and there's a lot of growth possible if the feedstock identification and sorting can be optimized, which they also do research here in Zwolle. And micronization and functionalization, I think, has also very big potential. And so with micronization, you do not specifically devulcanize, or not all the time, but you can recode these materials with certain chemicals to increase the bonding strength of the filler and the polymer. I think those types of technologies use a little bit less energy than devulcanization, but create very interesting mechanical properties. And I think those have a big place in recycling industry also.
How does CRP evaluate recyclability in practice? Do you prioritize standardized testing methods, or are you building new methodologies specific to rubber?
I think this is a very valid question, also because recovered carbon black is not a carbon black on its own. You have
and it's not pure carbon black. Yes,
exactly. And I also see the problem with recovered carbon black, that the metrics of carbon black don't work with the metrics of recovered carbon black, because recovered carbon black doesn't reinforce as much.
Yes.
So then you would look at the application side of things. We're very happy that the ASTM working group on recovered carbon blacks is effectively doing this, trying to commoditize a product that needs commoditization in order to scale up.
Yeah.
And I think this should happen, or would happen also for the other recycling technologies. So looking at devulcanization,
Yes.
how cool would it be to have a classification for devulcanized percentage, right?
In an ideal future.
Exactly. And then it would also be possible to commoditize certain streams. But I think it will be standardization of a certain set of tests, which will be mandatory to categorize and commoditize recycled rubber materials. Certain technologies do not seem to work for all applications. You probably heard about the Oryx Verbruggenplot with silica-filled thread compounds. Sometimes it's more difficult to determine the devulcanization rate for them. Of course, there will be new technologies slowly entering, but I think that the current ones are...
they are very valuable, the current ones.
There should be a new view on which characteristics are important, and understanding which are important, then you will also change a little bit your testing strategy.
A lot of the industry challenge sits with halogenated rubbers. How is CRP approaching the safe handling and potential recycling of these compared to non-halogenated streams?
I think for every recycling project to become successful, the sorting and separation step is extremely important. For example, in foams, it's very common to have EPDM and CR, which is halogenated, and therefore it will be more difficult to recycle them. In a perfect world, recycled materials would be separated firsthand and then would be recycled accordingly. CR and FKM have recycling methodologies also for themselves. They should be taking their proprietary recycling technology streams. So yeah, I think they should be separated.
Separated. Yeah. I agree. Are there cases where substitution or moving away from halogenated rubbers is a more realistic solution than recycling?
Yes, of course. In the end, I think in industries where halogenated materials are not allowed anymore, you need to move into alternative materials. And very depending on the application, you will find some neighboring materials for whatever characteristics possible. So yeah, prevention is always better than recycling.
You've spoken about building databases of material characteristics. What kind of data do you see as essential for enabling recyclability and traceability across the supply chain?
So the databases that we collect are basically on solutions. So we look at materials, technology, software, and even products that contain recycled or bio-based materials. So those are typically the material database that we create, that we fill, and that we have been a lot of fun doing so. So we found a lot of recycling technologies, and listing these is considered a database. If we look at which information is important to allow recycling, that's a very specific question on which material characteristics you need to know. And then it would indeed be the main polymer type, the polymer filler ratio, what type of fillers are in there, carbon black or some minerals. We also reach and rose, which in Europe is very important. Yeah, so these types of lists and materials, this is super challenging. What you can often argue is the fact that you didn't put it in there if you're recycling. So if you're looking at PAH, for example, from bicycle tire tubes, it's considered a bicycle tire tube. It was sold in Europe. It was according REACH at the time. So therefore, it's kind of allowed. And I think that happens with these types of materials that are being phased out as well. This is of course a problem that is growing because we're restricting more and more chemicals, and we want to recycle at the same time. In fact, we're working on a marketplace ourselves, trying to market waste streams from product manufacturers, because sometimes they don't have any idea what to do with their material, and how cool would it be to put it on a marketplace and see what recyclers think about it. In those cases, it becomes even more important to understand other types of data, not the rubber itself, but is it contaminated? Are there metal parts in there, or plastic, or is it fiber reinforced? Has it been standing outside with rain and mud, or is it completely clean and sterile, or even clean room? So that's kind of typical data for a recycling process to prevent damage in your recycling machine. And then for the rubber itself, those are the polymer and the filler ratio, etc. are important. But this is also, for example, for 6PPD and car tires, which is used everywhere. And so the leaching happens when you're in sunlight and rainwater with acidic rain. Luckily, there have been some studies that when you use polyurethane encapsulated rubbers like this, it doesn't happen as fast because polyurethane is kind of blocking the sunlight and for the leaching of 6-PPD. Imagine all the 6-PPD that you're basically reprocessing and re-entering the world and making cool products from outside.
Do you envision blockchain or digital product passports playing a role in rubber circularity economy?
Yeah, I definitely see that this is a big opportunity, and the reason why is that I was yesterday in a project trying to discover this. Digital product passport is extremely important for the traceability of the material contents, as you basically just asked. And I think a digital product passport would be super cool for every product that we carry, right?
Yes.
So for a t-shirt, we find it very normal to know what's inside. In the automotive industry, we know exactly what is inside, but the O-ring of a coffee machine, we have no idea.
Yes.
For the recycling industry in the future, it will be necessary to have digital product passports. And I think that certain industries like footwear, tires, I think these will be the early adopters.
Yes.
Where in the tires, RFID is already quite common. And I think for other industries, this will be very important for already sorting and separating the material streams.
Regulations in Europe are increasingly pushing industries toward circular models. How is CRP engaging with policymakers to make sure rubber isn't left behind in this transition?
So the platform is started as a knowledge platform. So we really wanted to understand what are the solutions, the possibilities with regards to rubber recycling and circular economy. So it's not the case that we wanted to step into the role of a lobbyist because already existing companies and associations are in place. In Europe, we have the European Tire and Rubber Manufacturing Association that basically talks with policymakers to make laws in favor of circularity, or that talks how it is possible and how it would not be possible. So the Circular Rubber Platform doesn't have to do that. We just collaborate with these types of organizations and we motivate them where needed. In fact, we do see that the plastics industry often gets kind of in forefront of regulation.
Yes.
If we look at the Green Deal, for example, many people talk about polymers, not rubbers or plastics or thermoplastics.
Polymers.
Exactly. So this is sometimes an issue. And in the Netherlands, this was also the case, where the Netherlands had a new law for mixing recycled and bio-based materials for polymers. So the rubber industry was taken into account as well. Luckily, the Dutch Rubber Manufacturing Association, they lobbied for this case and they explained how rubber would not be included, and then it was fine. However, this also has an effect on subsidies and grants from the governments because they focus on trying to motivate their laws and regulation, and then rubber is taken out of their scope if it regards the grants. So this is where we currently at the local level do also talk with the Dutch RVO, for example, the grant organization, in order to reincorporate rubber into this industry, because we think that really helps the circular economy locally.
But in a realistic way.
In a realistic way, exactly. Motivate the people that do good, basically.
Looking ahead 5 to 10 years, what would success look like for the Circular Rubber Platform?
So the Circular Rubber Platform has one big statement. We want to make rubber circularity the norm, and we want to do that in any possible way. So incorporation of recycled and bio-based materials, the support of regenerative materials in rubber industry, and the helping product engineers to design with circularity in mind. This is what we really stand for. So in 5 to 10 years from now, I really hope that we have a very big group of rubber specialists that help any company in the rubber industry to become more circular, preventing rubber incineration because we know how to recycle it and incorporate bio-based materials where possible.
I'm glad you said what you just said, because my last question, and maybe the most important one, if you had one message for the rubber product designers of today, something they should already start considering to ensure circularity tomorrow, what would it be?
Indeed, incorporating the idea of design for circularity would be one of the first things to start with. There's many courses on circular economy that will help you guide through the fundamentals of it. Well, if you want to design products for the future, you should learn about circular economy and design for circularity. And design for circularity means that you make a product that is, of course, necessary in the first place, that is made for more sustainable materials, and it's recyclable end of life, which means do not glue two very different materials to one another because it doesn't allow any recycling technology. make use of more monomaterial products, think about recycling before you make a product, and also think about why people need the product in the first place. Because every product that we buy but not use is already wasted resource after all. If you think about that before making the product in the design phase, you prevent a lot of waste being unnecessary, and you make sure that the products that the people that buy your product are considering sustainability also. I think it's very important to increase the awareness for the whole rubber supply chain, first of all, that we're not sustainable at the moment. Yes. If you look at the amount of synthetic polymers and the amount of carbon black that goes into the rubber industry, it's insane. Mm-hmm. And so in order to produce these materials, we use a lot of fossil materials, which will run out eventually. Yes. And so I think we have to be aware about that a little bit earlier in the process. And so I think if you would ask what I should say to any rubber product engineer or any compounder, is be aware what type of materials you're working with and make sure you use them to the best of their abilities.
Thank you so much for having us here today. It was a very interesting discussion and very eye-opening.
Yeah, thank you so much also for having us, and looking forward to make circularity the norm.
What an inspiring conversation that was. Talking with Enrico really showed me how many challenges stand in the way of making rubber truly circular, from the complexity of formulations to the realities of recycling. But we also saw just how many opportunities are out there. New technologies, new collaborations, and the growing community that believes in change. It will not be an easy road, but it's definitely a battle worth fighting, and one that I'm proud to share with all of you, my rubber hearts.